November 29th, 2023. Guys, you're looking at images of our sun from yesterday on the 28th. What we've had is a solar flare, very strong one, powerful. They're saying that it was just under the line of an X flare. You got that classic signature right there where the cameras are seeing and you get the overload. And some of the energy levels inside this actually did rise up past the X1 level. But check this out. Again, Earth-facing images from the Solar Dynamics Observatory. This thing's incoming. We're going to take a look at it. There's been a couple of other CME eruptions, but this is the strongest one. Now let's take a look at the tracking model itself on this flare. The sun is in the center. Many of you have seen this for years and years. The Earth is the green dot, and then you have two satellites that are showing in the same orbit as our planet. In the red, you got stereo B. In the blue, you got, stereo A. In the blue, you got stereo B. And these three charts represent both the Earth and these two satellites. So they're going to be very similar because right now the two satellites are very close to Earth. But I have seen stereo B and A be in like a triangle here, getting the back side of the sun or the side angles. But right now we're getting mostly front angles from these two satellites. They're very old. But what we're seeing, again, when I play this, right here, this green chart, both here in the plasma density and in radial velocity, which is solar wind speed in kilometers per second, the green lines indicate our Earth and then what's going to happen there, and then the red and blue indicate what's going to happen on the satellites. But normally when you see the plasma density, that's how thick and strong this incoming CME will be, guys. The density in centimeters cubed. The more higher proton levels, the harder the impact. And what we're looking at, this graph, they had to change it. Normally you'll see right here where it says 20 up to 60, that's centimeters cubed in the density. That's 5, 10, 15, maybe up to 20. But if it's going to be super high impact, and especially with a steep curve like this, we are looking at a very strong solar flare. Now, we play this through, and let's look at it. Here comes a couple of the smaller blasts right there, but this is going to be what they call a cannibal CME. Check it out. It catches all of it about the time it hits our planet, so it'll be a combination of all of the flares. I'm going to let it play through again. I'm going to stop it at the point of impact of our planet here. Coming up 11:29, that's today. Notice 11:30, boom, right here. Back it up just a hair. Right where we start seeing this start to rise. Right in here would be a safe bet, around 6. Now this is going to be midnight tomorrow night here in the U.S., but 0600 UTC time, that would be again midnight on the 30th. The UTC time is 6 hours ahead of the East Coast, so that's what we're dealing with here. But at that point, we're going to see a very sharp rise in the plasma density. The green line on the bottom, which is solar wind speed, normally is around 320 to 340 on a calm day. And this chart has been elevated also because it's going to be a little higher. 600 is right here. That's kilometers per second. You're approaching 1,000,000 miles per hour now. And you can see one jolt here, one here, and then the higher one right there. That's going to be putting us around 700 kilometers per second. Very fast incoming. You can see it. But again, at 0600, the planet will be fully involved. Now, at that time, the U.S. will be on the dark side of the planet, not facing the sun, not taking the initial impact as far as head on, but the tectonic plates of our planet will feel it no matter what side it's on. It's just a pressure on this planet. And I want to point out one other thing that I'd mentioned. This is one of the tracking model for one of the smaller CMEs that we saw launch out in front of this large one. And this is what I was talking about in the plasma density, guys. Look at here, 2, 6, and 10, not 60. They changed the graphs so that you can fit in the higher levels of energy. And you were dealing with about maybe reaching 500 kilometers per second. But all of these are going to combine. But I'm just pointing out the changes right there because that's the important part right there. High speed and thick density. Now, you've got 3 or 4 different satellites that pick up this X-ray flux. That's the strength of the flare coming in. Notice this X right there. This section, guys, is, let me put this a little easier to see here. This line right here, when it crosses this one, it's an X flare. And so look right here. This would be the GOES 16 long, and the sensors, again, put it touching that line and maybe just a little above it right there. So you might as well call it an X flare, But that's what we're dealing with now. And so we always watch for quakes when we see this type of energy coming in. Regardless of where you're at on the planet, if you're near a fault zone, always be aware of that. We have tracked them pretty successfully since the Fukushima event. We watched a series of X flares leave the sun. We tracked them. Japan was turning right into the sun that afternoon there, and when we saw the earthquake, and then we saw that tsunami that came in there and killed thousands and thousands of people, devastated the area, and we saw the nuclear plants melt down. And that was the greatest disaster, I think, to ever happen on the planet. But guys, we're going to be watching it. You watch it. It's a heads up. And if I get any updates on this, I will put them up. But we have seen the sun reawaken after a very quiet summer. Again, it's a heads up. Be safe.